In this video, I'm going to show you how I think about and build REST APIs with a full working example. So when I say REST API, I just mean a CRUD application. So an application that you can perform create, read, update, and delete operations over a database, usually with some business logic and some authentication applied. So what are we going to do? Well, I'm going to talk about the tech stack that I'll use. I'm going to talk about the routing and app structure. And really, this is how I think about building the application and sort of the foundation of where we're going to start from. Then we're going to talk about the file structure, my development setup. So I use Docker and Docker Compose for that. And I think this is a really nice development setup. And hopefully I can convince you that it is as well. Then I'm going to talk about the server, logging, environment, variables, and configuration, my database, which I'll be using Postgres and Drizzle, schemas and validation, error handling, auth, observability, testing, documentation, my CI/CD pipeline, and finally deployment. So really, this is everything that you need to know about in order to build a really high quality REST API. So this is not rocket science. This is actually pretty simple stuff, but it's really important that you get this part of your application right, because this is usually where you're going to build off from to sort of make your unique software product. Okay, so the first things first, the tech stack. So I'm going to be using TypeScript, Node.js, Fastify as the web server, Postgres as the database, and then Drizzle as the ORM. So there's a lot of other packages that I'll use as well, but these are sort of the building blocks that are going to form the basis of the application. So the reason that I'm going to be using Fastify is because I think that Fastify is just a really good quality piece of software. And I really like the ecosystem that comes along with Fastify. So you'll see that we're going to use actually a few Fastify packages. So there's other good alternatives to Fastify. Express and Hono, for example, are both reasonable alternatives. I just personally like to use Fastify. I'm going to use Postgres. The reason that I'm going to use Postgres is because I like SQL databases. I like structured databases. And I think that Postgres is the better quality database. And also it's the one that I am familiar with. And then finally, I'm going to be using Drizzle because I do like having an ORM. I like being able to create migrations and I like being able to have strongly typed queries. And I think the Drizzle is the best ORM. So another alternative might be Prisma. And I've actually moved from Prisma over to Drizzle just because I think that Drizzle is closer to what SQL is. And I just find it more intuitive to write. You can also define your schemas in TypeScript instead of the Prisma file, which I really like as well. Okay, so for routing and app structure, I want to draw a diagram so you can see really how I think about this application, and then we can refer back to that diagram when we get to certain bits like observability and testing. And then hopefully it'll make more sense why I've made the decisions around those things that I have. Okay, so I like to think about my application in terms of the life cycle of a request. So let's say that we have a user. And this user can be anything. This can be a browser. It could be another API. It could be anything really. And this user is going to make a request. And then that request is going to hit our application. And now it's going to hit our application at the part that we've exposed. And in my case, this is going to be Fastify. And now Fastify is responsible for deciding how this request is going to be handled. And really, it's going to be handled by a route. So here we're going to have a route. And this is, for example, going to be /v1. So we're going to version our API. And then it's going to be /jobs. So routes are plural. Some people like to have routes as singular. I like them as plural. I think it makes more sense. And then once we hit a route, we're going to come down to a controller. And our controller is going to be responsible for housing our business logic. For our route, we're going to need to make queries to the database. Now, our controller isn't going to make queries directly to the database. It's going to call a service, and then a service is going to have functions such as find user by ID. These are specific functions that are going to perform specific queries. And our service, this is going to hit our database directly. So this is the lifecycle of a request, and then we're going to send that data all the way back up. Well, not really from the database. So we're going to send it back up from the database to the service. Then from the service, we're going to send it back up to the controller, and then back up to the route, back up to our web server, and then finally back up to our user. So one question that you might have is, where does validation sit in this? Where does authentication sit in this? So the validation and authentication is going to sit at this very top layer here. So this top layer here is going to have some middleware. So from here, we're going to have middleware, and middleware might just be like logging, for example. We're also going to have, or really what we're going to do here is we're going to attach the user to the request. And then our route here is going to check. So whether we need auth or what type of auth that we need is going to be determined by the route. So we're also going to have another layer of auth here on the route level. And then the route level is also going to be responsible for the validation of the request. So really we're splitting the middleware and the auth up between the first two layers of our application. So I like to think in terms of layers, and that's going to be handy later when we talk about testing. So for example, which layer do we want to test from? Do we just want to test our services? Do we just want to test from our controller down to our service? Do we just want to test our route, or do we want to test from the user all the way down to the database in one test? And the answer for me is that I want to test from the user all the way down to the database in one test, and I'm going to show you how to do that. Okay, so this is the request lifecycle that we're going to follow, and then we're going to refer back to this diagram when we get into different parts of the application. Okay, so let's talk about file structure. So file structure is one of those things where it's not that important. You can create any file structure you want. In fact, you can create your whole application in one .ts file if you really want to do that. But the thing is you need to be consistent with your file structure. So don't just scatter files everywhere, but don't really put too much effort into thinking about it. And you can refactor it easily later on. Okay, so what I like to do is I like to have a source folder, and the source folder is going to house all of the code that I'm going to write. So you can see that there's a bunch of other bits of code out here. And so the Docker files, I did write those, but they're not inside of the source for our application. Okay, so inside of source, I like to have a DB folder. Inside of DB, I'm going to have an index. And now this index is responsible for setting up my database. And I've got a bunch of functions in here that I can import, and I can use those to connect to the database. So I have a async function here called setup database, and this is obviously going to return a promise. Inside of that promise, we're going to have our database connection, which comes from Drizzle, and it's also going to have the client. Next, I'm going to have a function that I can use to ping the database, and this is just going to verify that we are actually connected to the database. If we're not connected to the database, then what I really want to do is just terminate the application. I don't want to start up and continue if I'm not connected to the database. The whole thing is pointless if I'm not connected. So the next thing that I'm going to have is a database type, and I can just use this type throughout my application as I like. Then I'm going to have a teardown function, and this teardown function is just going to disconnect from our database. And this is really handy for cleanup, just to make sure we don't have any connections hanging around. Okay, so next I have a dev, and this just has a seed in it. You don't really need to do this. This is just because I was playing around, but basically this is going to seed the database with a bunch of data, dummy data. Okay, so the next thing is the modules, and this is where we're going to be doing most of the work. So inside of modules, I'm going to have my application. By the way, this is a job board. This is just a basic application. So don't take too much notice of the names of the files inside of the modules. This could be anything. So I'm going to have an application, and this just refers to a job application. Then I'm going to have a job, and this refers to a job posting, and then a user. Inside of each of these folders, you can see we pretty much have all the same files. So we have a controller, we have a route, we have a schema, and we have a service, and then we have a test. And we're going to have the same inside of all of these. So we have a controller inside a job, a route, a schema, a service, and a test. And so if we go back and have a look at our diagram, you can see here that we have a route. This is going to be this route here. We have a controller. This is going to be our controller. Then we have a service. This is going to be our service. So what we don't have on the diagram here is a schema. And a schema, these are just my schemas that I'm going to validate the request against. And then of course we have a test. The next folder that I have is test, and this is just going to have my setup script. So whenever I run a test, we're going to run this setup script. And in my case, this is going to use test containers. So I obviously have Docker running, and I'm going to set up a test container inside of Docker, and then I'm going to run my test inside of that container. The reason I'm doing that is because I can create an instance of Postgres inside of that container. I can run my migrations, and then I can run my test against a real Postgres database. And this gives me the best coverage, I think, for tests, and it is super simple to set up. So we can try this here with pnpm test. And now if we go have a look at Docker desktop, you can see a test container started up here, and then we're going to run the test inside of that container. So it took a while to set up, but once we get it set up, it runs all of these tests quite fast. So we have one failing test here, so I need to fix that. But that is for another day. And I'm going to go into the setup in more detail later on. The next folder that I have is my utils folder. And this is basically just a bunch of utilities that I'm going to be using throughout the application. So I have HTTP, and this just has one function in here. And this is for my HTTP errors. So whenever I throw an error, I'm going to throw a HTTP error, and I'm going to throw that error from a controller. So you can see here, I'm returning a HTTP error. And we're going to go into more details in the error handling section. But basically why I want to do this is because it makes sure my errors are all consistent. All of my errors are going to have a message, a status code, and a cause. And then I just have a schema here for my error. Everything is going to have a schema. We cannot have any input or output that doesn't validate against a schema. And that is very important. So we have other things in here like logging and metrics and my server. And we're going to get into these things in a little bit more detail later on. Next, we have my config, and config could really go into utils. It is really just a utility. Then we have main.ts, and this is our entry point for the application. Okay, so the next thing to talk about is the developer setup. So I like to use Docker for my developer setup. So you could just run the application in your terminal, having Node.js installed on your system, and that's all good. So the reason that I like to use Docker is because it lets me start the whole application up, including the database and other tools like Dozzle, all from one command. And then we can share these Docker Compose files with the deployment server. So later we're going to talk about deploying to Railway, and then we'll be able to share this Docker Compose file with Railway. So let's have a look at these Docker Compose files. Firstly, let's have a look at the Docker file. So the Docker file is very simple. We're going to be using Node 20 Alpine. We're going to create a working directory. We're going to do this, and I needed this because I'm starting this on a Windows computer. When I started this on my Mac, I didn't need this here. I think it is a difference between ARM and AMD. Okay, so we're going to move our package.json. Then we're going to install pnpm. This is just a personal preference. I like to use pnpm, and so we're going to have to install that with npm. Then we're going to install our packages with pnpm. We're going to copy the rest of the application. We're going to build the application. Then we're going to expose port 4000. And really, you don't need to do this because we're going to expose that with Docker Compose, which I'll show you in just a second. And then next, we're going to run our built application with Node. Okay, so we have two Docker Compose files. One is a Docker Compose and a Docker Compose.dev. So Docker Compose is what I want to start in production. And then Docker Compose dev, these are the things that I want to start locally, as well as overrides for the things that I started in the Docker Compose file. So when you go to deploy your application, you'll run the Docker Compose file, but you won't run the Docker Compose dev file. And I'll show you in my package.json how I start this. So if you type the command dev docker, by the way, you're going to be able to see the GitHub repository in the description below. And this is going to run Docker Compose -f. And then we're going to point to our Docker Compose because of course we need that. And then we're going to layer on our Docker Compose dev. Then we're going to call up and build and then in detached mode. So we don't want to tie up the terminal with this. So in here, I'm going to start my API. Of course, we need our API. We're going to have a health check endpoint. And this is just going to call this every minute and 30 seconds with curl. And then this is the endpoint here. And then we have a volume. And so this is because I'm using sessions as my auth. Next, we have Dozzle. So Dozzle is just a way to see the logs for your containers. So I can show you that. This here is Dozzle. So these are all the containers that I have set up. So if we have a look at API, you can see all the logs from my API here. And you can see when it started up, we got this using config. You can see the logs from the database. You can see the logs from Dozzle itself, the logs from Grafana, and from Prometheus. So I just like to have that because it makes viewing the logs much easier. The next thing that I'm going to use is Prometheus. So Prometheus is going to capture the metrics from our application, and then we're going to be able to visualize those metrics in Grafana. And I'm going to show you all of those in the observability section. So obviously, if you are going to start this in production, just here you have admin and password as the password. You want to change those. So set this to something that you got from an environment variable. Don't use admin password, please. Okay, so in my Docker Compose dev, I'm going to have a database. The reason that this isn't in production, and of course you need a database in production, is because I don't recommend you start the database up with your application. Of course, you do risk losing all of your data if you do that. It's much easier to use a managed service like Neon or even something on AWS like RDS. And then we have our API again. The reason that we have our API again is because I want to overwrite the environment variables and I want to set a command here. So this command is going to run our migration, and then it's going to use nodemon to watch our migrations folder and then run the migrations when something else is added. So I can, in my command line, run pnpm db generate, and then this is going to generate a new migration file. And then that new migration file is going to get run against our database. And so we're then going to have the latest version of our migration. And then this, of course, depends on database. We don't want to start up our API until our database has started up. Okay, so I'll give you a demo. I already have this application running, but to run it again, you're going to do pnpm dev and docker. And then this is going to rebuild the containers. You can remove this build command here, but I think it's kind of handy to have it. And this is going to rebuild the containers, and it's going to restart the application as well. So you might be thinking, well, I like my application to restart whenever I change a file when I'm running it in development mode, and that is going to happen. So if we have a look at these commands here, you can see that we're going to run pnpm dev, and pnpm dev, if we look at the corresponding package.json script, is going to run TSX, and it's going to run it in watch mode. So let's go over to our logs here, and we can just go save our main file here, save that, and you can see that our application restarted. Let's log something here, console.log, starting server, and you can see that we got that log here. So we are getting the new version of our application whenever we save a file. Okay, so the next thing is my server. I told you I'm using Fastify. How do we actually use Fastify? So I think I have a pretty good method for this, and it hasn't failed me since, and I've done this a lot, including in production. So what I like to do is inside of my source and utils, I like to have a file called server, and this is where I'm going to do all of my Fastify stuff. And in here, I'm going to export a function, and this function is going to be an async function, and this is going to be called build server. So build server is going to take our database connection. So of course we've connected to our database, and then we're going to start building our server. Then we're going to create an instance of Fastify, and I have the logger on here, and that is true. And you can see that here, we're getting these requests come in here, and you notice I haven't actually hit the application, but it is because we have Prometheus scanning the metrics endpoint. And we also have a health check as well. So that will come in every 1 minute and 30 seconds. So Prometheus is going to hit this metrics endpoint. I think it's configured to hit it every 5 seconds or so. So I said that everything is validated via a schema, and we're going to get into that later on, but all of those schemas are defined in Zod. And so to do that, we have to import this plugin here called Fastify type provider Zod. And this is just personal preference. Out of the box, you can use JSON schema for Fastify, and it's actually really nice. I just prefer Zod because it gives you a lot more control over your validation, and it's just something that I'm used to as well. So I'm going to register a plugin here, and to register a plugin with Fastify, you just call register, and then you pass the plugin in. So this one here is Fastify cookie. So I'm going to register that plugin, and I'm going to use Fastify cookie because I'm going to use sessions, and my session token is going to be stored inside of a cookie. And next we have a hook, And this hook is just going to attach the database connection to our request. And we can do that because remember, we injected our database into build server. So the reason I'm doing this is because I just want to be able to have a request and then call request.database instead of having to call the connect to database. Let's have a look at the DB and the index file. You can see that we have our setup database. So you could import your database connection from here, but to do that, you would have to have a database is equal to null, and then you would have to say DB is equal to DB. And in fact, you wouldn't define that as a constant. And you have to do that. And then you would have to export your database. And I don't like that. Personally, I would rather just inject the database connection into the request and then be able to call it from there. Next, we're going to have a hook for onResponse. An add hook is going to have different places that you can add hooks to. So you can see here, there's a bunch of different parts of the request flow that you can add a hook to. So I want to add mine on response, and this is going to record the request reply time. So if we have a look at this is just a custom bit of middleware that I wrote myself. And then this is going to get the success code. So if it's less than 400, then it's going to be true. Success is going to be true. And then we're going to get the method from the request. And then we're going to have a histogram inside of Prometheus for this. So I'm going to get into this a little bit later on, but basically this is just going to say for this request method and for this URL, we got this many success codes, and this is the histogram for how long those requests take. So if all of a sudden we have a request to / post jobs that starts taking 10 times as long, we can have an alarm on that request. That's just an example of something that you can do with observability, but we'll talk about that later on. Next, I'm going to get my secret key, and I'm just reading that in from a file. You can see here we have our session key, and then I'm just going to read that in from the file, and then I'm going to set up Fastify secure session. So you can see here, this is Fastify secure session. And remember I said that I like the Fastify ecosystem. You can see all of these plugins here that I'm using that come directly from the Fastify ecosystem. These are all official plugins. And so you get some sort of guarantee, not a real guarantee, but you know that if something's in the Fastify ecosystem, it's probably going to be very good quality. And then this is just my configuration for Fastify session. Now, we'll talk about Auth a bit more later on, but I'm using sessions just because it's really simple. You're going to want to use whatever makes sense for your application and whatever makes sense for your business. So if you get a job at a company and they're going to want you to set up a REST API, chances are they already have a solution for Auth, and you just need to implement that solution in your application. And the chances that it's this exact solution are not very high. So use the Auth solution that makes sense for you. Okay, so next hook we're going to have is on request. So this is the first hook that's going to get run. Whenever we make a request, we're going to run this hook here. And this is just going to get the user ID from the session. So because we're using Fastify session, we have this request.session, and we're going to get the user ID. And then we're going to get the user from the database, and we're going to populate the user on the request with the user from the database. Now, this is not very efficient, but it doesn't really matter because this query here is going to be so quick and not put much pressure on the database that it's probably okay to do it every request. If it's not okay to do this every request, you can put more data on the session. But I think this is perfectly fine. Postgres can handle a massive load of traffic, and so this is perfectly fine. Then we're going to add a decorator for authenticate. And authenticate is just another function here to say if we don't have the user on the request, then send out a 401. And if we do, then just continue on the request. And I'll show you later how I use this decorator. The next thing that we have in here is our Fastify Swagger. So this is going to set up our documentation that we're going to talk about later on. Then we're going to set up our routes. So remember inside of our modules, we had a route file. In our route, we're going to have a function. That function is just going to take in our server, and then it's going to call server and create a bunch of routes on that server. And then we're going to prefix that. So if we have a look at this route, you can see here that this is just post /, but of course, when you create a user, you want it to be v1/users. And so we prefix all of the users routes with that prefix. Same with jobs and same with applications. The next routes that we're going to have are our docs, our metrics, and our health check endpoint. So we can check that our application is up by going to our health check endpoint, and this just returns a status of okay. So the next thing that we're going to talk about is logging, and logging is a somewhat overlooked thing in a lot of applications, but it's extremely important. Being able to debug really relies on some good logs inside of your application. So for logging, I like to have a file inside of my utils called logger. And from here, I'm going to export my logger. And the package that I'm going to use for logging is Pinot. So I like to use Pinot because one, it's very simple to set up. It has a lot of configuration options and it's a very fast logger. And then thirdly, I know that it's a good piece of software because it was written by Matteo, who is also the creator of Fastify. So from Pinot, I'm going to import Pinot, and then I'm just going to call Pinot. It's just a function, and that function takes an object, and inside of that object, you can pass in your configuration. So of course you want to have a log level, you want to have a transport. I have my transport set to Pinot Pretty. So if I have a look at my logs inside of Dozzle, you can see that they're formatted really nicely like this. And I have a nice timestamp and stuff. That is because I'm using Pinot Pretty. So the documentation for Pinot Pretty does say to not use it in production. I have used it in production and it has worked well, but the documentation says not to. And so I obviously have to repeat what the documentation says and do not use Pinot Pretty in production. You really want to add some config here to say only do this if you have Pinot Pretty set to true. And then the third part of this is something that I really like, and this is an array of strings for redacting. So I want to pass in some strings here that I want to redact. And whenever I have that object, or whenever I log that object, and this is a key of an object, it's going to be redacted. So let's save this so it forces that application to restart. And you can see here that we're logging config, using config, and our database URL here is redacted. Of course, we have a username and password in that URL, and so we don't want to log that, but we do want to know that it was set, and we do want to be able to just log the whole config object. I'll show you how that is being done. So you can see here, config is just an object. It's a typed object here, and we're saying using config, and then we pass the object in as the first argument, and we're doing an info level log. So you can also use the logger on the request. I personally just prefer to create a logger in the utils and then import it. You can see here that I've just imported the logger inside of the controller. It's just a basic import, and then I'm calling that logger down here, and then we can pass in an object and we can pass in our string. The other thing that I want to say about logging is I like to prefix the log strings with the name of the function that the log exists in. So you can see here, this string here is prefixed with create application handler, and that is because the function here is called create application handler. I like to do that just because it makes it easier to find logs, and it makes it easy to identify logs as well. So here, for example, we have a very generic error, and this is database error. If we just had that without this part here, when we got that, it would be difficult to see where this log came from unless you obviously logged the call stack as well. So I like to add this prefix here. It just makes it easier to find logs. So the next thing is our config and environment variables. And this is the part of the application that I'm least sure about. So the reason that I'm least sure about that is because I'm using this plugin here called Zenv. And Zenv is just going to take a Zod schema. So you can see here, we're just creating a regular Zod schema, and then it's going to export our config and it's going to get it from .env. In fact, you can just remove .env because you'll notice in here, I don't have an env file. All of my environment variables are set by Docker Compose, which is another reason that I like to use Docker Compose for my dev environment. And then we can export this config here and it's all going to be typed properly, and we can set some defaults and everything. So the reason that I'm unsure about this is because Zenv is just a plugin that I created myself. So you can see here, I am the creator of this plugin and it works really well, but I haven't updated it for 2 years, mainly because it just continues to work. It's fairly simple. It doesn't do anything too complicated. It basically just loads your environment variables and then passes them through the Zod schema that you gave it. But of course, use this at your own risk. So another alternative to Zen would be to use JSON schema, and then you can use another package to convert your JSON schema to a TypeScript type. And then you can use a package called env schema. In fact, I think I probably have it installed here. Yeah, so this package here, env schema, again, this was created by Matteo. So you know that this is a good quality plugin as compared to something created by me. Okay, so the next thing is the database, arguably the most important part of the application. And I'm using Postgres as discussed before, and I'm using Drizzle as the ORM. So this is nothing different to a just regular old Postgres and Drizzle setup. So inside of my database, I have an index. Again, I'm exporting my setup and my teardown and my ping function. I have a function here to run my migrations. So I can call this function here and it's going to run my migrations. I don't really use this, to be honest, because the migrations are going to be run by my Docker Compose file here. And this is going to run pnpm migrate. And then this is going to run drizzlekit migrate, and that's going to deal with it for us. And the reason that it knows how to deal with that is because we have some config, some drizzle config, and this is going to say where our migrations live, the dialect that we're using, and our connection string. So from this configuration here, it knows how to run the migrations, of what database to run it against, and all that sort of stuff. The next important part of the Drizzle and Postgres setup is the schema. So if you're not familiar with Drizzle, basically you import the Drizzle package and then you can import different functions depending on the database that you're using. So if you're using MySQL, for example, you're going to have a different set of functions you import here. Then you define your table. So this table here is called users, and you export that on a constant called users. So this is just normal database stuff. We have an ID. This is going to be text. And then we want to default this. This is something that Drizzle is going to help us with, to a random UUID. And random UUID comes from the crypto package. We have this object here for timestamps, and I move this out into a different object because I want these timestamps to be the same on every single table that we have. So jobs and users and applications are all going to have these timestamps here. So again, Drizzle is going to manage this for us. So it's going to default the created at to now. And then for updated at, it's going to default to now. And then when we update the table, it's going to update it for us. Drizzle allows us to do a bunch of other things that are also included in your database. So for this example, I'm using a TS vector search. So I want to be able to search the title and the description, and I want to be able to set some weights on those searches as well. And this is just creating an index for the search. So if we have a look inside of the job controller, you can see if we have a look at the get jobs handler, we're going to be able to take in a search parameter here. And then we're going to pass that search parameter down to get jobs, and get jobs is a service, which is going to hit the database. And then if we have a search parameter, we're going to do some formatting on that search parameter. Then we're going to set some weights again on our query. So this is our match query. Then we're going to provide a rank based on the matching, and then we're going to be able to sort the results by the search query. I am going to create a full other video on how I did this full text search using TS vector. So if you want to see that video, make sure you've hit the subscribe button and turned on notifications so you get notified when I release that video. Okay, so where do we actually connect to the database? Well, we're going to do that inside of our main.ts. So inside of main, I have this function called main. Then we're going to get our database from setup database. And then, as I said before, we're going to pass that down to build server. And then later on, we're going to ping the database as well. In fact, we should move this up here. And then this will ping the database to make sure we are connected. If we're not connected, then we just want to exit with a status code of 1. So we only ever make requests to the database inside of services. So we can have a look inside of our services. You can see here we have job, application, and user. And then we're just going to get our database, and our database is going to be injected into the service. Let's have a look at the user controller. And you can see here that to create a user, we're injecting the request.database into the create user service. Then we're going to use that database connection to insert into users. So the reason that I'm injecting it into the service is because later on, if I wanted to just test a service, let's say I had a really complicated service, I might want to mock my database and then inject my mocked version into the service here and then just test that service. But I'm probably not going to want to mock my database when I'm calling a controller or testing a controller, sorry. So one other thing that I want to show about Drizzle that's really nice is if you have a look where we create our database, we're also including our schema. And to get our schema, we just imported all from schema. And the reason we're doing this is because it allows us to do queries that are actually really nice. So if we have a look at, say, user.service, you can see that we're doing a query here and we're calling db.query.users, and users automatically appears on our query and it's fully typed. So actually, if we remove this, you can see db.query. And you can see we get our applications, our users, and our jobs, and then we have other functions that we can call on top of that. So it provides a really nice interface for querying the database. If you don't get this here, just make sure that this type of database here is actually the type of whatever is returned from this drizzle function here that includes your schema. So you can see that I'm inferring the type from the return type of setup database, and then I'm getting the database connection from that. And so this is going to be fully typed with my schema. So the next thing to talk about is schemas and validation, an extremely important part of your application because you don't want people to be able to insert any data they want into your application, and you don't want to be able to just return everything from your application. So the way that I have this set up, which is something that I'm actually very happy with, I think it works really well, is inside of a module, I'm going to define some schemas. And these schemas are just Zod schemas, basically. So this here, well, actually, it's a mix of JSON schema and Zod. So you can see here we have tags, and tags are just going to be used to group your routes inside of your documentation. The documentation is going to be automatically generated for us. Then we're going to have the body on this request. So this is create application schema. So this is the schema that's going to be validated when we create an application. So the body of the request must pass this validation. Otherwise, we're going to get a 400 error back. And that 400 error is going to give us some nice messages about what exactly went wrong. Then we have our responses. And of course, when we create an application successfully, we want to return a 201. And we can provide another schema for what is going to be returned when we create an application. So we have this function here, create select schema, and then we're passing in applications. And what this is a package called drizzle Zod. And then we're going to be able to infer the Zod schema from a drizzle schema. So if we have a look at applications here, this is our Postgres table schema for our database that we created earlier. So what we're doing here is we're saying whatever is returned when we select an application, we're just going to return that with our 201 response. If you wanted to refine this schema here, you can do some different things. So let me have a look at the user schema. So here, for example, I'm calling transform on my email, and I want to transform this to lowercase. I don't ever want to store an email that has a mix of cases. But you could also do something like this. So we're doing create select schema for users, but we want to omit the password. We don't ever want to return the password. So even if we accidentally returned a password from this create user schema, it's not actually ever going to be returned to the user because it doesn't pass the schema. The Zod is going to remove that for us. So this makes our API just a little bit more secure. There's a bunch of other transforms you can do with Drizzle Zod. It's really powerful, and you're probably going to be able to get the exact schema that you want. So what do we do with these schemas here? So let's have a look at this create user schema. If we go over to our user route, so you can see that we're calling server.withTypeProvider. The reason this exists is because we're using the Zod Fastify plugin that I showed you earlier on, which is this Fastify type provider for Zod. Then we're calling .post, so we want this to be a post route. And then we can provide our schema, and this is expecting a Zod schema here. Then of course we provide our handler. So to use the types inside of our handler, because we have a Zod schema for our body. We want to be able to type our body. We have our request, and we're typing that as a Fastify request. And then this is a generic. So we can say our body, and we're just going to infer the body from this create user schema here. And then this is going to type the body here. So you can see that we have an email and a password, and these are both defined as strings. And the nice thing about this as well is because in this schema here, we can guarantee our email isn't email because we've called string.email. So you get all the really nice things from Zod, but you also get it inside of your Fastify application. Okay, so the next thing to talk about is error handling, another really important part of your application. So I showed you before that we have this HTTP error. And so this is just going to be a function that is going to return a Fastify reply with a status code, and then it's going to send a message and a cause. And this just means that all of our errors are going to be uniform. They're all going to have this response body here, and they're also going to have the correct status code because, of course, when we call this function, we're going to put in the correct status code. The next thing that I'm doing is exporting the object for this. So you can see we have a message, which is just string, and that is required. Then we have an optional cause. If we want to provide a little bit more information to the user, we can do that. Next, we have an object, and this is just going to be all of the error response codes that we want to handle, and we're going to pass this in as our error schema. So if we have a look at our user schema, you can see that we're just spreading this error responses on here. So let's go back into our controller, and from our controllers, this is where we're going to be using the error response function. We're not really going to be using this anywhere else. So we're going to try create the user, then we're going to catch the error. And if it's an instance of a Postgres error, and actually there's a better way to do this, and I'll try find the better way to do this. And I should update this one here because this number here is a bit arbitrary. You have to Google that, you don't know what it is, but we do have a package to handle this really nicely. Okay, so here is this package, and this is from Postgres. So this is the combination of Postgres and Postgres error enum. So basically Postgres error enum is going to convert those string numbers into nice enums for you. So you can see down here, we're going to get our error, and then we're going to cast it as a type of Postgres error, because we know that it really has to be a Postgres error. You can test that it is a Postgres error if you want to by saying, is it an instance of this, blah, blah, blah. You can do that if you want to. In this case, that would be pretty redundant. So then we're going to use our enum, and we're going to say this is a unique violation. If it is, then we're going to return the right status code, and we're going to return a error message as well. So this basically just converts the number into a nice enum for you. So that's really it for error handling. It's really simple. Just make sure you return consistent errors. So I'm going to talk about Auth very quickly. And the reason I'm going to talk about it quickly is because what I said before, where Auth is really going to depend on your application's requirements and your business's requirements as well. But I'm using Fastify Secure Session. Basically how this works is it creates a session, it encrypts it with this session key, and then it installs that cookie on the user's browser. So here's a little sneak peek of the Swagger docs that we've generated. And you can see here we have well, let's go log in by creating a session. And you can see here that we have this encrypted cookie here. And basically this cookie is useless unless you have that key, which only our server has. So this just contains a user ID, but the user can't see what's in there, and it's useless unless you have the key. So it is fairly secure. And I'm just setting that in a cookie with the cookie name, and then the expiry is 1 day. And then we just have some cookie options that we can set here as well. Okay, so observability, this is another really important part of your application. And if you do build something to put in your portfolio, include this because it's going to make you stand out as a developer because it's something that a lot of people overlook. So for observability, we're going to have two components. One, we're going to have Prometheus, and this is what's going to capture the metrics. And then two, we're going to have Grafana, and this is going to be used to visualize those metrics. So Prometheus is going to be a data source for Grafana. And these are two both free open source applications that are really common inside of the software development world. So the first thing you want to do is you want to have Prometheus metrics being captured inside of your application. You want to expose those metrics, and then Prometheus is going to scrape those metrics. So basically how this works is we have our application, and then we have Prometheus, and our application is going to have a /metrics endpoint. And make sure you don't expose this metrics endpoint to the world. Really only expose this to Prometheus, or at least secure it. Then we're going to have Prometheus here, and Prometheus every 5 seconds is going to scrape that endpoint there. And then it's going to store the data that we scrape off this endpoint. And then we're going to have Grafana, and Grafana is going to allow you to query Prometheus. So Prometheus comes with its own query language, and then we can use that to query Prometheus, and then we can visualize these metrics in a nice dashboard. So I'm going to show you how to set this up, and then I'm going to show you an example of a dashboard that you can create. So inside of my utils folder, I have a metrics file, and metrics is just going to export the metrics that I want to use throughout my application. So I'm using a package called Prom Client, and I've used this package for a long time. It's a very good package. Next, we have our request response time histogram, and this is going to measure the response time of a HTTP request. Then we're going to have some labels on here. One is the method. So this is this a get, post, put, patch? Then we have the route. And so the route is going to be, for example, /jobs or /v1/jobs. Or if you are getting a job by ID, then the route is going to be /v1/jobs/job ID. So don't include the actual job ID here, just include this literal string job ID. These labels need to have a low cardinality because you don't want to be querying for the status code of a specific job. We have other tools to diagnose issues like that, like logs. So these are meant to give you a high level overview of how your application is performing. So I want to be able to query for this route, not for this route for each specific job, if that makes sense. Next, we're going to have a request counter. So basically, we're just going to count how many times a route was hit, or a method was used, or a status code was served to a user, or we can do success. So this is just going to be true or false. One thing to note is there is a paradigm of how these labels are used. So you'll notice they're all strings. Whenever we have success, it's true or false, but it is the string true or false. The other thing is that we always use snake case in these labels. You can use camel case if you want. That's just not the convention for Prometheus. Okay, so I reminded myself here to mention that these have low cardinality. So next we're going to have our database query time. So we're going to have our operation, and then we're going to have our success metric here. Next, we have this function that I showed you earlier just to measure the reply time. And then this is going to increment the request for us. So this reply time here is going to be done for us in some middleware. So this on-response middleware here is going to measure the reply time for us. So that metric is set up, it's done. But we do have some other metrics in here, like the database query time histogram. And we can have a look at that. This is called on every single service. So let's have a look at our diagram again. So we need to make a decision where in this stack do we want to measure things? Where do we want to count things? Where do we want to find bottlenecks? So the place that I want to find bottlenecks is this whole request lifecycle from the user down to the database. And I want to be able to see this on a route level. And I want to say, if this route is particularly slow, then I can dive in and I can see where it is slow. Let's say it's making lots of operations to the database. Well, what are those operations? Well, to figure that out, we can have a look at the metric that just measures this part here. So I'm going to have two metrics. One is going to measure the whole life cycle. The other is going to measure the thing that is most likely going to be slow, and that is our request to our database. You could add metrics at different layers if you want. So for example, you could have a metric that measures from your controller down to your database, but I don't think that that is very useful because we can tell what those routes are by using this request metric over here. So just think about your metrics in terms of layers, like which part of the stack do you want to measure the response time for. You could also have metrics for your middleware, your validation, that sort of stuff, if that is something that you suspect might be causing issues in your application. Okay, so to do this, we're going to call our database response time histogram. This is just the function that we created earlier by calling client.histogram and then passing in our configuration here. We're going to get back this end function here. So we can call it end function when we return from the function. So I'm going to call it twice here, once with an error and once with success. So if we catch an error, success is going to be false. And if we don't catch an error, success is going to be true. And then we have our operation here. So we're repeating this. Usually what I would do is I would say const metrics labels is equal to an object. Then I would put operation and I could put success. And then we can just put these in here and then we can just spread it on the error case and then just override success with false. So this is going to make sure that we don't have any spelling mistakes, because if you have spelling mistakes, you're going to have the metric with the spelling mistake there forever. So don't do that. So the other thing that I want to mention about metrics is always prefix the name with the application. So you can see here in config, I have this metrics prefix, and this is just going to be app. So let's say you had 100 services inside of a microservice architecture. You want to prefix every service with what that service is. So let's say you had a user service, you would want to prefix this with user, because if you have metrics that all have the same name, you need to know which service that metric is coming from. So always prefix your metrics with something. So the last thing inside of our application is just serving these metrics out. So we have this endpoint here for metrics. We're going to set the content type to whatever Prometheus.register and then content type return. So prom here is just our Prometheus client. So I think it just sets it to, it's just a constant, sets it to text plain, the version, the character set, that sort of stuff. But don't hard code it yourself. Just use this function here that returns the constant for you. Then we're going to get prom, register, and metrics. And then this is going to execute and it's going to return the current metrics for the application. So Prometheus is going to hit this metrics endpoint. Your application is going to gather up all the metrics, serve it out into a plain text page. Prometheus knows how to read it. It's going to ingest it and it's going to store those metrics. And you can configure how often this does that. So we have a look at our Docker Compose. I think in here we have Prometheus and we have a Prometheus YML file. And in here, this is going to set the interval to 15 seconds. And we also have a scrape timeout of 10 seconds. Okay, so let's have a look at this metrics endpoint here. So this is our localhost 4000, which is where our API is served, and our metrics endpoint. Typically, your metrics would be served from a different port. You would start up a different server on your application and serve it from a different port. The reason for that is because you probably want to have the metrics only available internal to your VPS. I'm not going to get into that, but basically you don't want to provide a public endpoint for your metrics, because if somebody wanted to DDoS you, they could see how much of the actual resources that you're using. So if we have a look here, you can see that we have this histogram here for metrics, and this is our custom histogram here. This is the one we set up, and you can see we have our help text here. Then we have our database query time in seconds. We have a bucket, so you can see here get user by ID, and these are the operations we're performing on the database. Then down here, we have a bunch of these default metrics that we didn't define. And the way that we got these is by registering some default metrics from our Prometheus client. So I'm importing prom, which by the way is just our Prometheus client, from our metrics file. And then inside of my main, I'm going to call prom.collectDefaultMetrics, and I'm going to prefix this with my metrics prefix. So this is going to collect a bunch of different things that is very useful. For example, it's going to collect the event loop lag. It's going to collect the CPU usage, the memory usage, that sort of stuff. So if your application had a memory leak, for example, you would be able to see on the chart your memory grow and grow and grow and grow and never drop off. That would indicate that you have a memory leak. So you can see here, whenever we refresh this page, all the numbers are changing. Okay, so inside of our Docker Compose, we also created an instance of Grafana. Now, this instance of Grafana is special because we have a bunch of dashboards that we have pre-configured. So if you clone this repository and you run the application in Docker, then you're going to get all of these dashboards as well. These dashboards are just configured inside of the Grafana file, and then there's a JSON file that just tells Grafana how to set this dashboard up. Then if we go to localhost port 3000, we log in with our username and password. Remember, we set that to admin and password. We go over to dashboards. We're going to be able to see the two dashboards that we have here. So one is the application metrics. These are my custom metrics, my database response time, and my HTTP response time. And then we have our default metrics. So let's have a look at our default metrics first. This is showing our CPU usage over time. This is showing our memory usage over time. Then we have our event loop lag and our active handlers. So this is showing it for the last 6 hours. Of course, I haven't had this application running for that long, only about an hour or so. You can refresh it, and then that's going to get a new set of data. But the dashboard can be set up with an interval. So I think the interval is probably the same interval that we're scraping the data with Prometheus. Next, we can have a look at the application metrics. So this is showing the HTTP response time, and it's just showing everything that is really slow. So you can see up here, we have some that are taking 5 seconds. Not sure what they are. You could add another label to this. So you could add the route, and then that would give you some more information, and you could really dive in and see what's happening there. So you can see the success and response rate. So you can see here, this is not correct. The yellow should be error. So I think the label is just wrong here. No, sorry, this is correct. This is just showing true or false. So this dashboard could be displayed a little bit better, but basically this is just saying all of the requests have been successful. We've only returned things that are with a status code of less than 400. And next we have the query success versus error rate. So you can see here, we only have successes, but you can see how long our database queries are taking as well. They're actually very fast. But if you had one that is very slow, you could come into here, you could have another label for the operation that you're performing, and then you would be able to see which operations are slow. Okay, so the next thing to talk about is testing. Again, another very important part of making sure your application performs exactly how you want it to perform. And I like to use Vitest just because it is super fast. And as I mentioned before, I have a test setup script, which is going to use test containers. And this is going to set up a container that has Postgres installed. And then after each test, I'm going to truncate all of my tables just so I'm working with a fresh database every test. And then after all of my tests, I'm going to tear down the database and I'm going to stop the container. First, let's have a look at our diagram. So when we write a test, we need to decide from where we're going to test, how far down into the stack, and where we're going to start. So for example, we might just want to test this layer here from our service to our database. If we have a really complicated query, we might just want to test this. We might want to mock our database, and we might want to test that it's being called with what we expect it to be called with. In my case, I just want to test from where the user makes a request all the way down to the database, and everything in between is included in the test. So for example, if I make a request that doesn't have authentication and this route requires authentication, then my test is going to fail because I haven't properly authenticated. If somebody removes that authentication, then my test is going to fail. So let's have a look at the user test. So I'm going to make a describe block for the route that I'm testing, and this is to create a user. Then I'm going to create a test for the scenario that I'm going to test under. I'm going to create a fake email and password. And then this is why I like to structure my application with all of the Fastify stuff in this build server function, is because it makes it really easy to test. I can now create an instance of my server. I get that app, and then I can inject a request into that. And this is a really nice feature of Fastify. So we also get our database. Let's have a look at where that comes from our test setup. You can see in our test setup, we define the lexically scoped database and client and everything. And then we redefine that with our database once we have a connection. We can then import that into our tests, pass that into build server. We get a version of our app that we can now start making requests against, and then we can make assertions against the responses of those requests. So here, I'm not testing whether the user was actually created. I'm not looking in the database saying, was this user actually created with this name and stuff? You can do that. That's no problem. You have your database connection here. So you could make a query to the database if you wanted to. Basically, all I'm testing for here is that my status code is a 201. The user was created successfully, and the return message is what I expect. Here, I'm testing the scenario of a missing email address. So I'm just passing in the password, and then I expect this response to be a 400. I think I forgot to show before how routes are actually authenticated. You can see here to log out, you're deleting a session. So you have this pre-handler here, and I'm going to call server.authenticate. The reason that we can do that is because inside of our server file here, I'm declaring a module for Fastify, and I'm putting this authenticate function on here. And authenticate is just this function that I showed earlier that's going to test whether the user is there. You could have different handlers. You could have one for make sure that the user that is making the request owns the job that they're trying to update. So for example, you could get the job ID out of the request params. You could query for the job. You could make sure the user is the owner of that job, that sort of stuff. And then you could put that as middleware on your route. So you could have an array of middleware here that's just called before a route is allowed to be served. If a user isn't authenticated and they try to call this, they're going to get that 401 response that we define here. Okay, so how do we do things that require authentication inside of our test? This request here to create an application requires that we have a job, and to create a job, you need to be logged in. So I have this function here called getCookie, and basically what this is going to do is it's going to create a user, then it's going to call our login endpoint. It's going to get the cookie from that. And then once we have that cookie, we can just put that in the headers of our request, and then we can continue on as normal. Okay, so let's talk a little bit about documentation. Now, this isn't documentation of how to use the application. This is generated Swagger docs. So if we have a look in our server, and you may have seen this before, we have a plugin called Fastify Swagger. We also have another plugin called Fastify Swagger UI. So Fastify Swagger is going to create the JSON for your docs, and then Swagger UI is going to provide a UI for that JSON. So let's have a look at this. And basically, we're just going to register the Fastify Swagger plugin. We're going to provide some info about our application and what version of OpenAPI we're using. The version of our application, which just comes from our package.json, then our server URL and port, and then we're going to have some tags. You don't actually need these tags here. We're going to provide some information about the type of security that our application uses. And then we have this transform here, and transform is this JSON schema transform. And the reason that we have this is because we're using Zod as our schemas. So you can see that this JSON schema transform comes from Fastify type provider Zod. Okay, so we've registered Fastify Swagger. Then we need to register our Fastify Swagger UI, and we want to provide a route for that. And then we can provide some information about the UI. So you can provide some cause information. You can provide some other information about, say, CSP headers, for example. So if we go to our localhost 4000/docs, then we get these documentation here, and we can actually interact with our API. So you saw me do this before when creating a session, and you can see that this is grouped by users here. If we collapse all of that, you'll see default, and then you'll see auth, and then you'll see jobs. This is because we have those tags on the schema. So if I go back to user.schema, you can see we have tags here, and I've tagged this with user. We should see one down here with auth, and this is just a grouping for the route. So this route here, this login, will appear in the user grouping, and it'll appear in the auth grouping. Another reason that I like to use Zod as the schema validator is because we get some really nice default parameters here. See this user at example.com, this just comes from the Zod plugin, and otherwise it would just be a string. And this just means that we can go click try it out, and then we can execute this, and we're going to get our response back. So our response here is user already exists. So this is going to tell us the responses that we can get. We can get a 200, 400, all of those errors that we defined before. And you can see our errors have a message and a cause. So the other thing about docs is I provided a JSON version. So you can type .json on the end here, and you're going to get the JSON version of your Swagger docs, which is really nice. So you can import this into Postman, for example, if that's something that you want to use. Okay, so the last thing is our CI/CD pipeline. We want to run our tests, and we may want to deploy our application when we push up to GitHub. So for that, I'm just going to be using GitHub Actions. In here, I just have this action here that is going to run my test. It's going to run some linting, and then it's going to run my test. So I'm not going to get into how this works. Basically, this is just a very simple setup. It's going to install the dependencies, and then it's going to run a pnpm command. So if we go over to the repository for this application and we go to actions, you can see here that I've pushed some things and these actions have failed. If we go into one of these runs, you can see both the linting and the testing has failed. So I'm going to make sure I get that fixed. But basically, it looks like it didn't install pnpm correctly, which is fine. And then it's going to be the same for the tests. So these two actions basically do the same thing, except for the command that is run at the end. This one runs test, and then this one runs lint. You could combine these into the same job, but I like having two different jobs to show here. And I don't think it takes any longer to do that. It does them in parallel. So the last thing to talk about is how we would deploy this application. So personally, I would use Railway. Railway is a really good platform for deploying your application. And the reason that I would use this is, one, because I've done it before, it is super simple. And two, because we can use our Docker file here to deploy the API and to also deploy Dozzle and Prometheus. And this Docker compose file here would probably work out of the box. We may need to provide some environment variables inside of our Docker file here, but out of the box, this is probably going to work. If you do this, make sure you just don't run the dev Docker compose file. So that is how I would build a REST API. Again, if you need any help setting up your REST API, make a post on the Discord server or on X. If you enjoyed this video, please make sure you leave a thumbs up and make sure you subscribed and turn notifications on. Thank you for watching, and I'll see you in the next video.